Okay, so let's look at our assignment data lesson 6. I'll go to the draft version here, and if we look inside the assignment, we'll see that there's a lesson, so a notebook that has what we needed to learn, and then another document, the exercises. Okay? And so you want to first do this descriptive lesson. Now I'm going to show a video, we're going to go through it now, and then we're going to have some exercises you want to do. So that'll be a separate video if you need help with doing those. So we'll open it up, and we'll do the usual drill, which is make our own copy. And I think I'll call this video copy. Video copy, and I'll do the check mark there. Okay. And so the first point that they make is that we don't, as human beings, want to look at every single point of data. Okay, we need to do some kind of summarization. We need to do a summarization of it. Okay, and so normally you're going to be doing research, you're going to be collecting data. But the great thing is that when you're practicing, you don't have to even use someone else's data. You can just go out and create it yourself. So Wolfram's really good at that. Okay, so remember we have that random integer function. Okay, and we can just, so the example here, we're going to do 50 values. And we're going to do 50 values between 8 and 18 years. So that's going to simulate doing a medical research study, in which you have 50 subjects in your study, and they range in age from 18 to 80. Okay. And so each time you execute that, you'd get different things with the random value. But the interesting thing you want to think about is that computers can't really do randomness. So they have a pattern when they're going to do it. And so what they have is that, okay, you want a random, and it'll look random, okay, but give it this seed of 12 and see what happens. So if we look what happens here, okay, we got 27, 18, and we got that list. Okay, and let's just for fun, let's run it, and let's run it through a sort. Let's see if we can do that. So we're going to say okay, so we got input here, and we're going to say sort square bracket. Let's see if we can sort that. Okay, and you see when we sort it, so out it came. Okay. We got 23, 24 through 80. And now let's do the exact same command again. And notice how we had C12, and okay, so I did that command, but I forgot I need to sort. So I'm going to put sort in there. So I'm going to wrap sort around that. And so it looks like we got something different, right? We got two 80s. So I thought we would get something similar, but the seed random allows for controllers, by seeding the random with integer, we can get reproducible results. Well, it doesn't seem to be true here, does it? So let's try again. We'll do seed random 18 to 80, 12. We'll execute that. And we get 27, 18, 64. So it actually is the same in terms of, let's see, 73, 36, 73, 73. So it does look like that result that we gave up there. Now you would think that when we did the sort, somehow that changed it, right? So we got a different sort here. Huh, that's interesting. But if we just do the seed random, okay, we're getting that same pattern, 27, 18, and that. And then what if we do, say, seed random 13? So see if we get 27, 18, 64, and we don't, right? So so it appears to be that it's true. I'm not sure why the sort wasn't working. Okay. So they're going to say, well, okay, let's do it, but let's do it with seed random 1, 2, 3. So they gave it that key and said, okay, and then the next time you do that, you're going to get the same thing out. And so we see that that's what's happened here. Okay, so, and you can try that out and play around with it. Okay, and then suppose that you wanted to, so let's take a look at this and say, okay, well, I want to do seed random 1, 2, 3. Okay, but I need more subjects, right? And so we'll say age long. Okay, we're going to do a long one. So we do is, okay, we want to have a whole bunch of subjects, right? And so that's the amazing thing, right? With a computer program, it doesn't care what you tell them, right? And so I want to do a study that goes with people through 90, and I want to have 1,000 subjects. Okay. Can I do that? Yeah. So Wolfram doesn't care, right? It doesn't charge you by the guy. So there we have it, right? So we've got age long, and it has all those values in it. Okay. So if you could imagine how long it takes to get 1,000 subjects, so my wife, does this medical research, and you have to put out, flyers and ads on Facebook and try and get people to sign up, and so to get 1,000 people is forget it, it costs thousands and thousands of dollars to get that many people to sign up. Here we just got it right here. Okay, so age, that makes sense, right? So age is one thing, you can put them in order. We'll be able to do a lot of stuff with it. And then you'll have things in your, like you might say, typical question, how much pain, rate your pain on a scale of 1 to 5, right? Or you might have just answers, do you live in 1, an apartment, 2, in your own house, 3, in the, in an RV, 4 in somebody else's house, right? 5 on the floor. So, but those questions, you assign them 1 to 5, but you can see that's not really, it's an answer. It's not really a number in the same sense that your age is a number. And then we have another variable here, so we're going to do the country, okay? And so so the country, so we had 50 people, we have their age, and we have what country they're from. And then the last variable that I want to talk about is height. Okay, and because we're scientists now, we're going to do 1.50 m, 150 centimeters to 196. And so we get this distribution of the height. And so we have these values, and the idea is we're going to look for some kind of pattern. And by looking at the pattern, it will help us then to summarize. So, in other words, if you look at all these ages, right, who knows, right? Who knows what the age is? And so we're going to look at some ways that you can summarize the data. All right, and so we have the average or the mean, right? And that's something you can run. And what you want to look at is, what does this notation mean? You might say, oh, I don't want to learn this notation. Well, it is a very nice summary. So what it's saying is that from 1 to n, so for n people, okay, I'm going to get their age and add it all together. So that's a summation. So I'm going to add all the ages together and divide it by how many people there are. So it's a really nice way to explain what you do in getting the mean. Okay, I make a sum of the first person, x1, all the way through to xn. Then I divide by, the age of person x1, x2, and then I divide by how many people there were, and that's going to give me the mean. And this, so you might say, well, what the heck is this? Well, that is the Greek letter mu, and it's not a coincidence that it is the letter that makes the M sound in Greek, just like pi is the letter that makes the P sound for perimeter in Greek. Okay, so we've got all these guys. So take a look at this this summation. So that's a summation, and I think that's a sigma, right? So summation sigma, the letter sigma in Greek. So you start to see sort of the method and the madness of this naming. Okay, so the age, the mean of age, and the n makes it into a decimal. If we don't do the decimal, the /n, you see that we get that kind of less easy to deal with. So let's try mean of age long and do the same thing, /m, and see what we get. And so now you see, so we changed for age long, we set up to 90, and you see how the mean changed a little bit. And well, what happens if we go to age long and we try it again? All right, so we went up here and we did our random generator, and so we said, okay, now let's generate it. So let's generate it again. Okay, but we use the same seed. We use the same seed. So now we go down and we say, okay, let's see what happens. With our mean, the mean change. So our mean was, so we'll do it again. The mean on, oh sorry, mean on the age long. Okay, and it was 55.2383, and we run it again, and we get exactly the same thing. Why is that? Well, because we use the same seed. Okay. So let's change the seed. All right, we're going to change the seed, and we'll do, let's do this, and we'll change it to a different output. Okay. So we're going to change it to seed 321. Okay, so let me put that in there, and we'll put it in seed, and we'll change it to seed, so we're going to get a different one. And so say 321, and that'll be age long 2. Okay, so we have a second one. And we generate all those values. And we'll go down and we'll say, okay, let's see if the mean changed. And so should it change a lot? Well, it's still over the same range. We copy that in there and we say, we're going to see if age long 2, another set, how the mean changed. So I run it again and see how it's slightly different. And that's what you're going to expect, is that as you do these random generations, even though you say the same range, it'll be different. Okay, so that it helps you to work on stuff, is that you don't get the same data, so you can see how things change. Okay, so we look at the mean height. Now, another interesting thing, and one that we have learned a little bit about in math too, is the geometric mean. So when we're looking at segments in similar triangles, we had a geometric mean. And what that is showing is, instead of the sigma, to add things together, we have, it looks like a big pi, that we're multiplying everything together. Okay. So with the product. So remember p, pi, well here, pi for product. We multiply. So we're going to multiply everything together and then take the square root. So in a simple case, we do the 3 times 3, let's say that your two values were 3 and 12. So you do 3 times 12, take the square root, and you get 6. So 6 is the geometric mean of 3 and 12. All right, so now that we've introduced that, you're kind of curious as to, well, what if instead of geometric mean, I just do the mean? Okay, that's what I'd be curious about anyway. And is there and why did I get that? Why didn't that work there? Input, mean, height, geometric mean. So I already had it up here, mean height 172.86. So you see it's very close. But that's strange, right? Is that I did, if I do it up here again, see if okay. So when this happens, when you don't get an answer anymore about it, okay, then you say, maybe I have to go back to where I generated height. Okay, so I did this notebook a couple days ago. So I go back in here and I go height, and now I say, okay, I did height. And you can even double check by just typing in height and executing it. and see if anything comes out. Yeah, so there's height. Okay, so what I did, I went and executed the statement that created the height. So now I say, okay, I'm going to go back in, and there you go. So it comes out. Okay, so they're very close, the mean and the geometric mean in that case. Median. Okay, so median age, median height. Let's just go into our age long and look at that. So let's do the median of age long. Okay, so that's the middle value. What if you don't do the NN? Let's see what happens. Okay, so let's try that on this one. So it was 175 point. If we say that. Okay, so not a big difference. So I guess it would just average 2. So usually it's going to be a whole number. So median of age long. And what about median of age long 2? Okay, so median of age long 2. And now we have mode. And so mode, there isn't an explicit one for mode, but you can see what we have here is that we have counts for each value. And the interesting thing is that, so you can do counts and you can do tally for the same thing. You can say, okay, so of our 50 people, how many are from each country? And you see how it didn't like that? Okay, so it didn't like that, and it's the same reason as before, right? It's the same reason as before, is that we need to go and execute this again. So we open up the notebook, but we didn't re-execute things. And there, I think there's a command, so I'll learn about how to do that. There's a command where you can execute everything in it. So now if I go down to tally country, oops, I have to go up here, go to the right place, and I hit enter. You can see now we do the tallies, and what's the difference in the tallies is that it makes it into this ordered pair. So there's a list, and it says, okay, for France it's 9, Canada 5, whereas here it's a slightly different format. Okay. This one, the heads counts is just saying, okay, well, what is in country? And it's an association, so it's saying there's a country associated with each person. Okay, so we use the tally, and we can sort them. So here's an interesting thing, right? Is you say, okay, well, if I sort, I can say greater, which is say I whatever's the most. So the most was 15. But what happens if you don't say greater? Then it goes from the least to the greatest. So we call that the default. So the default for sort is to go from in ascending order to get bigger. The greater order, this is descending. So I go from a bigger to a smaller to a smaller. Okay, so now we have first way to find out how much variable there is to look at the range of values. Okay, and so this last one's kind of nice, min-max. So let's do min-max on age long. Okay, so let's see what happened with that one. Okay, so our min-max. Okay, so that didn't work at all, did it? Oh, you know why? So you can see why it didn't work. It's because I spelled it wrong, right? I put that X in there, capital X. So it was still blue. So our min-max is what we would think, 18 to 90. Quartile. Quartile is the 25th percentile, the 49th percentile, and the 60th percentile. So let's try the same thing. Let's do quartiles with our age long. Okay. Hey there.
Hi.
Just a second, I gotta close out this video I'm working on. Alright, and so that's the end of this first half of the video. We'll be back with part 2.